Next, we'll calculate freezing point depression. Example 14.8 says, calculate the freezing point of a 1.7 mol aqueous ethylene glycol solution. Ethylene glycol is a non-ionic solute. To calculate the change in freezing point, that's calculated as the mol concentration times the K sub F for the solvent. This is a colligative property, so it doesn't matter which solute you have, as long as it's non-ionic and doesn't dissociate in solution. So we're given the mol concentration. We just need to look up the K sub F for the solvent, and then we need to calculate the change in freezing point. Alright, so the delta T is calculated as 1.7 mol times 1.86 degrees C per mol for water, which gives us a change in freezing point of 3.2 degrees C. The normal freezing point for water is 0 degrees C, so we just subtract the 3.2 degrees C from 0, giving us a freezing point for this solution for negative 3.2 degrees C. You might be wondering how we knew to subtract. Well, this is freezing point depression, and the freezing point is always depressed. So you subtract the change in freezing point. Next, we'll calculate the freezing point of a 2.6 mol aqueous sucrose solution. Sucrose is also a non-ionic solute, so we don't need to consider ionization here. The change in freezing point is equal to the mol concentration times the K sub F for water, so that's equal to 2.6 mol times 1.86 degrees C per mol. So that's equal to 4.8 degrees C. So our freezing point will be lowered by 4.8 degrees C. So the freezing point for this solution is going to be equal to the normal freezing point for water, which is 0, minus 4.8 degrees C. So that's equal to negative 4.8 degrees C.